Hey, what's up everybody? My name is Chris. Thanks for coming by to watch my second video. And I hope not only to watch, but also to get your hands dirty with some Python code. The main goal of this channel is to encourage people to write code. We'll build many projects step by step from scratch. And today we'll make the first one. And we're gonna scrape some basketball data. So I'm gonna show you how to get the HTML code from a website, navigate through the HTML and filter what we need, and then turn it into a Pandas DataFrame. And I think I'll split the project into two videos, and in the second one we will filter and sort and aggregate data with Pandas and visualize data. And if you're asking why we use basketball data, there are two reasons. The first one, I love basketball. And I'm serious. This is the reason. And the second one, there is plenty of basketball data in the internet. And I know not everybody loves basketball, but this video has another purpose. I want to give you a blueprint of how you can gather data on a subject that's important to you and turn it into a data science project. Explore it. Go with your curiosity. Why? Your projects will be unique. And what's even more important, because it's fun. And when you have fun, you will enjoy it. And if you enjoy it, it's more likely you'll spend way more time with projects. And also, you'll learn faster. Remember what Jim Quick says. Learning is state dependent. Okay, let's begin the project. Let's create a new project on a local machine. My initial idea was to do this in a Colab notebook because it's more convenient. It already contains all packages we're about to install. Just create a new Colab notebook and it's ready to go. However, I had some issues. The same code that works fine locally doesn't compile in Colab. I tried to debug it, but without success. So we just create a Python notebook in Visual Studio Code. Visual Studio Code is an editor that I use every day, and I highly recommend it. Let's create a new directory for our project. Please note, I'm using Ubuntu. If you're on Mac, the next steps, I believe they are the same, but if you're on Windows, they will be slightly different. You can always try to create the project as a Colab notebook, but you may face the error that I already mentioned. The data we're using is the list of NBA players who made at least 9 3-pointers in a single NBA game. Actually, it's a list of all the games when it happened, because there are players that show up on the list many times. So I'll go to my terminal to create a directory. I call it most trees and go there. Right now I want to create a new Python virtual environment in order to install all the libraries and packages that I want to use in the project. We create the new Python virtual environment by calling Python 3 because I'm using Python 3 -m venv, and I'm going to call it venv. And if you look into the directory right now, you can see venv folder, and it actually means it got created. We want to activate it by going with source venv bin and activate, and we know it's activated when it has venv at the beginning, or whatever is the name of your virtual environment. So the next thing I want to do is to update pip. I think it's a good habit to have, to always use the latest pip version that there is available. And I also update setup tools. It's installing right now. And the next step is to install all the libraries and packages that we're going to use. And there are a few. We're going to need requests, beautiful soup, pandas, matplotlib, seaborn, and an IPython kernel. Okay, we installed the packages. We can see the list of them by going with pip freeze. As you can see, the list is longer than the 6 libraries that we wanted to install. It's because many of them need other libraries in order to run. So this is why the list is way longer than what we actually wanted. But it's always like this, so we just have to accept that. Okay, let's open our Visual Studio Code. We just need to type code and the dot, which means our current directory. And this is our Visual Studio Code. The project contains only virtualenv directory. So let's create a new Python file. It's not gonna be a standard Python script. It's gonna be a Python notebook. So we're going to call it most3s again and create a Python notebook. Let's try to run the first cell with print, for example, hello. And it's not running because Python notebooks need a kernel. And this is the list of kernels that I have installed on my computer. And I want to use the local one, which is with the dot, which is the current directory. And let's just select this one. And it has run. So our Python notebook is running successfully here. Let me give you a brief introduction to HTML. I'm going to keep it short and give you only the information that you need to understand web scraping. So this website that we chose for our data, and actually every website in internet, is either written in or converted to HTML. And what's cool about that is that this HTML code is actually available for us to read it. I do it by clicking right and selecting inspect, and it's opening the window on the right where I can see the whole HTML code. And what you need to know for now is that HTML consists of 2 major parts. There's a head and body. Head is what we don't see on the website, but it contains all the parts that are crucial in order for the website to run correctly. So there are different settings or imports, but it's out of the scope of the video. So I'm just going to leave it. And there is a body, and body is everything that we can see. And the body is built as a tree of objects. So if you can see here, there's like body is like the highest level, and there is like one level deeper, and this div, for example, has some children because it's called children and parents and siblings, and this child has another children, and this one has more children. So there are many levels for the tree. And what body contains are tags, and each tag has some purpose. So for example, there are tags for text, like paragraphs and headings. So let me just take this tool that I can use in order to select some part of the website, and when I click it, it's going to lead me to the HTML part where it's written. So as you can see, there is a P, which stands for paragraph, and this usually displays text. But if you see some table, like for example here, and if I go there and go one child deeper, you can see there is a table. So if there is a table, there must be some rows, and TR stands for table row, and table row has children, which are basically table cells. So like I said, each tag has some purpose. So if you can see any link on the website, you can expect to see a tag. And let me just select this one. These are links. I clicked here, there is an A. Or if there is, for example, a button, this is going to be a button. If there is an image, it's going to be an IMG tag, and so on. So each of them have some purpose. But if you look at the website, you see many div tags, and divs have some different role. You can think of them as containers, so they just hold the website together. The layout just doesn't break because of the divs. And the next thing I'm going to explain is that if we take, for example, this div, you can see that it has an opening tag and the closing tag, which is just the same as name of the tag, but the name is followed by slash. Like this here means it's a closing tag of a div. But what we see on the website, it comes from between the tags. Okay, this div has another child, which is h2 for heading, and it has B tag, which stands for bold. And only between the tags we can see text that is displayed on the website. So we can think of it like what's between tags is what we can see, and what's inside of the tag is how we can see it. Like for example, this div has some attributes. It has a class attribute, which is a CSS class with style. So this style says, for example, that this text is going to be centered. When I click here, I can deactivate it, and if you saw it, it moved to the left. And now it's again in the middle. Next, I'm going to show you how to extract data from the website. We're going to use the beautiful soup library from Python. It is a great tool that allows us to search and navigate and filter through the HTML tree. So the data that we're interested in comes from the tables. On the website, there are 3 tables altogether. This is the first one. And let me just use this cool tool again. So if I select it and click here, you can see here's the first table. If I scroll down and use the tool again, here's the second table. And if I scroll down again, here's the third one. So the information I want to collect comes from first columns. I want to know how many 3-pointers a player made, name of the player, team, the team for which he played at this game, and also at which season it happened. So to collect the data, we are going to have to make a HTTP GET request. So let me go back to our notebook first. For the web scraping, we're going to need two libraries from the ones that we already installed. So it's requests, and also we need Beautiful Soup, and this is how we import it from BS4 import Beautiful Soup, and we've got what we need right now. And to make an HTTP GET request, we need to define the object and use requests with GET, and as a function parameter we need the website, the link for the website. When I do this, I create a request object, and let's just check what the status code is. When it's 200, it means it was successful. So right now we've got request object and we want to convert it into a Beautiful Soup instance. We're creating Beautiful Soup instance by calling soup. We're going to call it soup. We're going to call Beautiful Soup, and we need text from the request, and we want to parse it with HTML parser. And let's see what we have in soup. This is our soup object. If I open it, it's a massive text file actually, and you can believe me on this one, this is exactly what we get here. This is exactly the same what I showed you previously as the HTML code for this website. So at this point we've got a soup object that has all the information from the website, and we're interested in the data, as I mentioned, in the data that comes from the table. And for that, Beautiful Soup has a very convenient function that is called find, and we're just going to use it for now. We're going to create a table from soup, and we're going to use find, and as attribute, as in we're going to use name of the tag, which is table, as I already mentioned. We want to data from table, which is a type of tag, and this table1 is going to return the HTML code from the first table. So right now this table contains exactly what comes from this from the first table. It is the first table because we used find and the tag name, which always returns the first tag that is called as this parameter. So we called it with parameter table, so it returns the first table. So right now, everything that's here, we gathered that in this table1, and again, it's a very long one, but if you have a look, here's the first row. I think it ends it ends here. Yeah, here's the closing tag, and here's the second row here. So if we have a look, it says 14 here. Here it says Klay Thompson, Golden State Warriors. So actually this is the data that comes from this row. it's very long, so it has all the rows that come from the first table. Okay, let's go back to our notebook. So right now we have the data from the first table. Actually, there is an attribute that allows us to search a little bit quicker than we find, because if we just write zoop and then dot and tag name, we're getting actually the same. So if we compare them, table 1, I'm just checking if it is the same as zoop.table. It is true. So it means that the table that we got with find table returns exactly the same as zoop.table. The find function is a little bit more powerful. We can add other attributes there to make searching more specific. But if we call find only with a tag name, we can just change it to dot and then tag name. And there is also a function that allows us to find all the tables, for example. So the function is called find all. And let me just show you the length, or maybe no, not. I'm just going to call zoop and then find all. And just like before table, it returns all the tables. So the code from all the 3 tables that we have on this website. And let me just show you the length. How many objects we got in return. And as you can see, there are 3 tables, which actually is true and we already know it. Right now we want to gather the data. We want to go deeper in the tree and gather the data from the first row. So we already defined table 1. And as you could see, this table 1 contains of many table rows. But if we want to get the first one, let's just call table 1. And just like I showed you, the tag type, which is table row. And if I gather this data, we see exactly what the first row contains. So let me show you this again. This is our table row with 4 TDs, which are table data cells. And we also have here TD, and another 2, 4 altogether. But we okay, so right now we've got the first row of the first table. Let's just call it row 1, table 1, here. Sorry for that. And let's just see row 1. This is exactly the same. And Beautiful Soup has 2 types of objects. There are tags and navigable strings. So first of all, let's try to get this first cell. We're going to do it just exactly like before, which it's called cell 1, and we call row 1 ED, which is this first cell. And let's check what this cell contains. And like I said, this is the first cell, and this is only what's in between between opening of the first TD tag and the closing. And if we check the type of cell 1, this is beautiful soup element tag, which is one of the objects, one of the kind of objects. The other one, it is, like I said, navigable string, and we can get it by calling string function. And right now it returned only what comes from between the tags. So this is actually the only information that is displayed on the website. This comes from here because this is the first row and the first cells from this table. And by calling the string, we get exactly what comes from in between opening and closing tags. And type of that is, like I previously mentioned, navigable string. Okay, so now you know both object types from Beautiful Soup. And you can already see that when we get the information from the whole tag, let me just display it here again. There is a lot of information. There are many tags, and each tag has its attributes, and the information that we want to read is pretty difficult to find. Like here is what's interesting, or team, or season, or player. So to make it easier to read the data, we want to get rid of all the tags. And we can do it with this cool function called getText. So let me just show you how it works. Row 1, getText. And let's see what we get. We get the information along with new line. This is what's left after we delete all the tags. So for example, here we get rid of this tag, and at the end there is actually no text, but we're going to the new line to start another tag. And this is this new line. Let me just maybe print it because it's easier to read this way. And yeah, like this we can see it better. So like first line, it has nothing. Second line has 3 pointers. Third line has nothing. Fourth has player, and so on. Here, nothing and nothing. So 2 new lines. And this is how it got only text using the getText function. The getText function has also an attribute that is relevant, and it's quicker to use. We can use row1.text, and this is exactly the same what getText returned us. However, we can use it only if we call getText without any parameters. And getText is more powerful, and it has 2 very cool parameters. First of them, it is called strip. So let me just comment here with strip. And I'm going to call row1 getText with strip true. And it got rid of every new line. So the text is a little bit better to read. However, as you can see, there is no white space in between, or no comma or nothing. So getText has another parameter called separator that we could use. I'll just copy this and call it with separator, let's say, comma. And right now, all the cells are separated by the comma. So as you can see, there is 3 pointers, player, team, season, win, lose, game, and there is a comma in between all of them. I'm going to leave it like this because later we want to convert the data into an array, and we can use also very convenient function called split, and we're going to split it with this separator, and this is how we're going to convert data into array. But let's just leave it for now. And maybe I'm just going to tell you one more thing. Separator is actually a default parameter. So if we move it there, we're getting exactly the same. So I just called the same function, but got rid of this key argument and moved a parameter to the first place. And this is how we get information from the first row. We can and maybe what's still important to say, I'm just going to save it as info string and show you the type info. So it's a string type. It's not like a string from Beautiful Soup that return navigable string. It is right now a standard Python string. And as I previously said, we want to convert our string into array. So let me just show you how I want to do this. I'm going to call info string and now split. And I'm going to call it with comma parameter. I'm just going to use exactly the same parameter as before. And let's see what we get. And we get array. We get an array with the information that we want to have. I already said I don't really care about this one, not for the project. So why not just slice it to first 4 cells? And this is how I got rid of this win-lose game. And let's just save it as info. Yeah, and right now we've got our info that's interesting to us. Yeah, cool. So I showed you how to gather data from the first row, and actually first 4 cells from the first row. But we want to data from all the rows and all the tables, and we want to loop through all of them. So for that, we're going to use our find all again. I'm just going to add some comment here. Loop through all the tables and rows. So we're going to use find all again. Maybe let me just show you again that we've got 3 tables. Loop find all table, and then max table. There are 3 of them. Okay, and right now for each table, let's check the length. Let's see how many rows we've got in each of them. So for each table, I'm going to say table find all and table row. I want to print it. Print. Okay, so the first table contains 29 rows, the second one 43, the second one is slightly longer, and the last one has 121 rows. So this one is really the longest one. But actually what we want to do, we want to show the data. So let me loop through the tables and loop through the rows in table find all. I'm going to get the data just like before with info string equal row get text, and we're going to separate it and strip to, and let's see what we've got there. Print info string, but because we saw there were so many rows, let me just slice it to the first 6 rows. So actually we can see we get the header again and the first 5 rows from this table, and they are here, and then we move a little bit down. This is again the header from the second table, and then we've got Tim Hardaway Jr., Stephen Curry, Jaylen Brown, Tim Hardaway Jr., Stephen Curry, Jaylen Brown, and with the third one also Curry, Patty Mills, Curry, Patty Mills. Okay, so that's enough to prove that we're gathering the correct data from the tables. However, we are not interested in the headers, so let me just ignore the first row, and then let's ignore, let's get data only from the first 4 cells. So we're going to do the same as before with info string, and then split with comma. And when we do this, you can see we've got, so first we got rid of the header rows, and we've got the information. There are actually 7 of them. So let me again slice it. We want 4 of them. Okay, cool. And right now we've got really the information that we wanted. So it's the number of 3-pointers, player, team, and season. However, if we have a closer look, there are also players and games that happen during the playoffs. Here's playoffs, and it says here, and it actually extends our data by 1 more column. So as you can see, for Damian Lillard, this is the first name that comes from the playoffs. We've got playoffs here and then team, and we don't have anything about this season. I think we're going to... We have to separate the two right now. I mean, we want to get this information if something happened during the playoffs. So, and we have to build it slightly differently. So I'm going to go with a single if and check if info. Let me just hold the complete info, and I'm going to say it's info array. And if let me just display it again. So if at the third position, so there's number of threes, player, and then third position, which we're indexing arrays from index 0. So this information is in index 2. So if info array with index 2 is equal to playoffs, let's say playoffs is true, sorry, and right now let's print info array only for them. So as you can see, it happened for Damian Lillard. What happens if we increase that? Okay, so right now we see more information, and it displays only with it happened during the playoff. But what we need when we want to combine information, we already said that we want to know 3 pointers and then player and then team and then season. And this is going to be our info. But for the playoffs, this information about player comes from first 2 cells. So right now we get 3 pointers and player. And then we have to ignore this one and then gather team and season. So again, info array, but this time from the 4th to the 5th. And let's see what we get right now. Okay, it's cool because right now we ignored the playoff and we get the season. And we're going to go else. And the playoffs and the info going to sorry. Okay, so if there is no playoffs, let's say it's not in the playoffs, but info we want to gather comes from first 4 cells. And let's see what we've got. Okay, we cleaned it a little, so even if it happened in the playoffs, we still get number of threes, player, team, and season. but we want to add the info if it happened during the playoffs, and we just add it like this. So we've got another information if it was during the playoffs or not, and it is mostly false, but for Damian Lillard it is true. Okay, cool. Let's save the data. Let's create a list, an empty list for that, and let's append the data as info, and let's display data. Okay, so we just created a list with all the information that we want, but right now we want to do it for each row, and let's say we want to display only the first 10 rows and the length of data. Okay, so the first 10 rows are actually the first 10 rows from this table until Steph Curry. Yeah, the last 3 are Steph Curry's. So Kobe, Steph. Okay, seems good. And we've got 190 arrays, positions. So our array has length of 190. So we collected the data from 190 rows, which is what we could expect because it says here that it happened 190 times in the history of the NBA. So we've got our data right now, which is already great. The next step we want is to save the data, to move it to Pandas DataFrame. So for that, I'm just going to say create Pandas DataFrame. And we didn't import pandas yet. Sorry. And we need to get some columns names. And we've got information from 3-pointers, made, player, team, season, and the last column is playoffs. So let me just say made threes as the number of 3-pointers made. Let's say player, and then team, season, and playoffs. Okay, we've got 4 columns, and let's create data frame. I'm going to call it most in game PD data frame, and let's say data is equal data and columns is equal columns. And let's see if it's working. It is. Okay, cool. So we've collected the data from the website, saved it as an array. We had to filter it a little bit, and right now we moved it to Pandas DataFrame. Let's see some info again to make sure we've got everything correctly. So we already know we've gathered the data from 190 rows, and all of them are non-nulls, which is already great, and we've got our 5 columns. So everything seems to be working. Let's have a quick look at one more thing. Let's just filter the data and see how many games come from the playoffs. It says there was 17 such games. So let's just try to filter it. Most in game, and then we want to check playoffs and just info. We don't really want to filter anything, but there you go. There is 17 entries, and again it's 17 all over the place, which is exactly what we expected to become. I'm going to save it as a CSV file, most in game to CSV, and let's just call it again most trees in game CSV. And I want to get rid of index, because when we are going to read the file again, it's creating one additional index that we don't need. So right now we saved it to the CSV file, and there you go. Here's our CSV file. So what we managed to do, we collected the data from the website, filtered it to only what we need. We separated to see which games came from the playoffs, and we also had to handle it differently. We converted it to the Pandas DataFrame, and also created a CSV file, which right now is what we're going to work with in the next video. So there you have it. I just showed you how to use Beautiful Soup in order to scrape data from the website. And also you learned some basics of HTML. And this video is already long enough, so I decided to finish it here and create the next one, where we're going to have a closer look into the data. I decided to do that because maybe there are some people that already know web scraping and they're more interested in just seeing the results that I'm going to show using pandas and visualization tools like Matplotlib or Seaborn. So thank you for this one, and I'll see you in the next one.